Hello, welcome to Advent of Code Day 9 with today's challenge called Disk Fragmenter. So another push of the button leaves you in the familiar hallways of some friendly amphipods. So what is this? Okay. Good thing you each somehow got your own personal mini submarine. The historians jet away in search of the chief, mostly by driving directly into the walls. While the historians quickly figure out how to pilot these things, you notice an amphipod in the corner struggling with his computer. He's trying to make more contiguous free space by compacting all of the files, but his program isn't working. You offer to help. He shows a disk map, which is our puzzle input, he's already generated, for example. And we have this. So the disk map uses a dense format to represent the layout of files and free space on the disk. The digits alternate between indicating the length of the file and the length of the free space. So a disk map like 1, 2, 3, 4, 5 would represent a 1 block file, 2 blocks of free space, 3 block file, 4 blocks of free space, and then a 5 block file. A disk map like 90909 would represent 3 9 block files in a row with no free space between them. Each file on disk also has an ID number based on the order of the files as they appear before they are rearranged, starting with ID 0. So the disk map of 1, 2, 3, 4, 5 has 3 files. A 1 block file with ID 0, a 3 block file with ID 1, and a 5 block file with ID 2. Using one character for each block where digits are the file ID and the dot is free space. The disk map 1, 2, 3, 4, 5 represents these individual blocks. So we have this, and this is for the example above. And now the meat. The amphipod would like to move file blocks one at a time from the end of the disk to the leftmost free space block until there are no gaps remaining between file blocks. For the disk map 1, 2, 3, 4, 5, the process looks like this. So we move this to here, this to here, this to here, this to here, this to here. Okay. Okay. Cool. This is this example, our test example. We collapse everything. Okay. The final step of this file compacting process is to update the file system checksum. To calculate the checksum, add up the result of multiplying each of these blocks' position with the file ID number it contains. The leftmost block is in position 0. If a block contains free space, skip it instead. Okay. Continuing the first example, the first few blocks position multiplied by its file ID number are 0 times 0, 2 times 9, 3 times 9. Why did we skip the 8? 4 times 8, and so on. I'm not really getting this. So the file, to calculate the checksum, add up the results of multiplying each of these blocks' position with the file ID number it contains. Okay, but the blocks are not atomic. So the leftmost block is in position 0. A block contains free space. I mean, there are no free spaces anymore. I'm not really understanding this. So 8 contains free space, allegedly, so we skip it. Continuing the first example, the first few blocks position multiplied by its file ID number 0 times 0. Yeah, this is this. Oh yeah, you just go one by one. Oh shit, yeah. I don't know. I overcomplicated this now in my head. So yeah, that makes sense. You just multiply the number by its position, basically. So compact the amphipod's hard drive using the process he requested. What is the resulting file? System checksum. Okay. So how should we do that? We could just do it like it's done here, but that would take too long. I think the input is too big to do it like that. So we would have to do it a bit smarter. If you just went and took this 2 and inserted it into this 3 here. Of that work actually. So we go here, we take those, we put that in, then we get to the end, and then the indexes intersect. Okay, so I've already done every input parsing. I parsed it as a string, but I see it would probably be better to have uh, it as an array of integers. So let's do disk map. We're gonna do it like an array of integers. And now for each element in disk map string, we are going to append the converted value to the disk map, something like that. What's the problem? It go. That will run to end. Alright, so you just do -0 supposedly, and of course convert it to an integer. Okay, so let's see if that does anything. Yeah, that looks fine. Okay. Now we should probably do left is equal to 0 and right is equal to length of the disk map minus 1. So I'm guessing it always ends with a block, not free space. So we don't have to do any major checks, I think. And we just do this while left is less than right, supposedly. And now we put the right pointer to space. And we're gonna have another, how is it called? Let's call it compact. So let's call it variable compact, which is going to be the compacted disk, so an array of integers. So first of all, we put the right pointer to the free space. So now we have to read. So we just take, so currently we are at, the file position, so not free space. And we have to move the files to a compact space. So we just, and we have to do ID count as well, right? ID count is 0. And now we just do for I equals 0, I is less than map of left, and we increase the I. And we append ID count to the compact disk. And after we're done, we increase the ID count. And we also increase the right pointer. Okay. Right pointer points to free space at, I mean the left pointer, what am I saying? Left pointer. Left pointer to free space. Left pointer points to free space at content from right pointer. What is this? Oh, never used, okay. Left pointer points to free space. We have to add content from right pointer. Now we assume the right pointer content is still it's not free space basically. So what we're gonna do is we also need the ID count from the right side, which is going to be, so the length is 5, we have 3 IDs, right? No, we have 2 IDs. Let me check. So for length, for length 5, we have ID of 2, so 5 divided by 2 is 2. All right, that seems to work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. For 19, We should have 9 then. Yeah, we have 9. All right. Yeah, so this is basically length of disk map divided by 2. And we insert until we can't anymore. So 4 4 disk map of right. So while this is bigger than 0, and disk map of left, which is free space, right? So, and this is more than 0 as well. We, if right still has content and left is still free, move and move. So what this means is we decrease the right, we increase the left, and we append to the compact, we append ID count right. All right. And then when this loop fails, we have to check, did it fail because we ran out of free space or because we copied all the contents, right? So if loop and because lack of content, if disk map of right is equal to 0, we have to move the right pointer to the left. We put the right pointer to the left, and we encounter free space to the left, right? So I guess we have to decrease it by 2. I don't know if it's gonna work, but let's see the example again. So we arrive at this 7. So we get to this 6, or rather we get to 6s, 4 6s. So we get to which point? This, I guess. Yeah, this 4. We start decreasing the 4. So the indexes here are the same basically, right? No, they're not here. And then here they become the same, but there's no point. Yeah, when they become the same, it's fine. It's the end. So yeah, well, they have to, left has to be less than right. This should work probably. Okay, this should be okay, I guess. We move the pointer and then we do what exactly? We can try and copy everything again, right? We also have to decrease the ID count, right? It's kind of it. Now, if loop ended because lack of free space on the left, continue normally. Okay, so now we have to figure out this. So we have to start the copy process again. So we have to run this again, right? So what would be the cleanest way to do this? Let's just for now, I'm just gonna copy this because it's basically the same thing. I'm just gonna copy this and paste it here and change this to while, or rather for. Shit. Like that. And then let's put but I think this should kind of work. I'm not sure, but let's see. Print line compact. Right. And one more thing, I'm gonna make another test file called test2. No, test2, where I'm gonna input 1, 2, 3, 4, 5. That's it. Okay. Let's run this and first read from this file. Runtime error, index out of range. Line 71. Okay. So while disk map of write is bigger, left is bigger or equal to right, we have to break. Alright, this is a bit weird, doesn't look correct. Or maybe it is, I don't know. Let's see. Not entirely. 2, 2, 2, 2, 2, 2, 2, 1, 1. So the 2s are getting bogged down there. Why is that? I have this check. Oh, this should also be minus minus, of course. No, it's the same thing. Oh, it has to be minus minus here as well. Yeah. And even weirder. No, so let me. So let's try commenting this out, just to see what happens. Oops. That's wrong as well. So I think the problem is, so we append the ID count right until we run out of space. Yeah, that seems right. And then if, oh, I should probably do it like that actually. If disk map of left equals 0, we should just continue. So we do, yeah, of course. We should, I should have increased the left pointer here. Probably don't need that, but we'll see. Yeah, now it's working, I think. So we have 2 2s, 3 1s, and 3 2s. 2 2s, 3 1s, and 3 2s. Yeah, that's correct. But let's make it nicer. Like I left minus minus. Will this make any difference anyway? So if we ran out of space, we have to move. Otherwise, we start copying the next one. Maybe I should. Maybe I should make it like that. So for disk map of right, so I just keep copying until we run out of space, right? Like that, right? We can just do that. So we can do that. Do that until the left pointer fails, and when it fails, we don't need to do any checks, right? But we can just decrease. No, why decrease the left pointer? So we just increase the left pointer. I hope I didn't mess up right now. Yeah, I messed it up. Um, oh yeah, of course. So now let's just put it the way it was. Left plus plus. No, how? What was the? Uh, Left plus plus. Yeah, let's just leave it at that for now. Let's try the slightly bigger test. Okay, I'm not sure about this one. I'm looking at it on the other monitor. Let's see. 00998111888277733364465555 and 6. And I'm missing 1 6 here. That's because of this, I think. So what if I make it less than or equal? Then I get too many 6s. Right, we have maybe we have a slight problem now. Maybe just an edge case which might not come into effect on my real input, but I would like to fix it anyway. Both the same one. So I'm just gonna, if the left is equal to right on same file, add if any parts left. So we go in and try adding. So we have file map. How is it called? Disk map. Sorry, disk map of left I plus plus compact append. We have to append the ID count, I guess. Let's see. Yeah, that fixed the issue. Let's just, for completeness sake, check this one as well. I think it's correct. All right, let's try the big input now. All right, I have to do the calculations. All right, so what do I have to do? So for I equals 0, I is less than length of, no, length of compact actually, I plus plus. and we need a sum. So sum plus equals I times effect of I guess. I just put this in braces just to be sure. And yeah, of course, you have to print this. Print I. No, sum. Let me do it. It's correct. Let's comment this out because the input is quite big. System cannot find. Okay. That's a big number, scary number. But I am quite relieved to see that that's the right answer. Okay, let's see part 2. I hope it's not too complicated. So upon completion, two things immediately become clear. First, the disk definitely has a lot more contiguous free space, just like the amphipod hoped. Second, the computer is running much more slowly. Maybe introducing all of that file system fragmentation, yeah, was a bad idea. The eager amphipod already has a new plan. Rather than move individual blocks, he would like to try compacting the files on his disk by moving whole files instead. This time, attempt to move whole files to the leftmost span of free space blocks that could fit the file. Attempt to move each file exactly once in order of decreasing file ID number, starting with the file with the highest file ID number. If there is no span of free space to the left of a file that is large enough to fit the file does not move. The first example from above now proceeds differently. Okay. Isn't that actually kind of easier than before? Okay, sure. We're just gonna make a function called part1 because I guess it's different enough that we can put it in different functions. Take this and paste it into this function. I don't know why I put this here. All right, and we have to put in the disk map, obviously, which is an array of integers and not much else. I think we have to also copy this pointers, and that's it. And then we do compact 1 for part 1, and we put in the disk map, and we put the oh shit, okay, we put the compact, what's happening, compact 1, compact 1, and also we have to return an array of integers, which is going to be the compact, and that should be the same now. Yeah, okay. We also comment this out. Part 2, so we just copy this and we're gonna try and make some changes. Paste. Part 2. Okay. Fortunately, I think this will require quite a different process. I'll be right back. Okay, I'm back. So let's try and think about this. So attempt to move each file exactly once in order of decreasing file ID number. Starting with the file with the highest file ID number. If there is no span of free space to the left of a file that is large enough to fit the file does not move. So we move 99 to here. We move 888. We can't move it actually. And we move 777 here. And we move 666. Well, we don't move it. Uh, we actually move 444 here, and then we get to 333, which we don't move. And oh yeah, I see, I see. Okay, that's okay. It's fine. I figured this out. Okay. Um. So we've got part two. We've got two indexes. This is okay. I don't think we need the left index, to be honest. No, I don't think we do. Um, I don't think we need the compact thing either. We will just use the disk map. And how are we going to do this? Okay, we're going to need some kind of struct, I think. Oh, it might not be necessary, but it feels like the easiest thing to do. So we can signify for each position what ID this position has. So Let's probably just make this struct. So let's do type disk part struct, which will contain size. Okay, gonna be an integer, and it's gonna contain the ID, which is gonna be an integer as well. So first, we're gonna make a disk map clone of disk part. So we need the disk, the disk part map, which is gonna be disk part, an array of disk parts. Okay, this seems fine. And then we go in, and for each element, we actually have to know the index. We go through disk map, and if I send2 equals 0, that means this is free space. Else, that means we have a file. So what are we gonna do? We're just gonna append to disk map the disk part. Now, if it's a free space, we're gonna append the element and the ID is gonna be -1. And if it's a file, we're gonna append disk part element again, and this time we're gonna do the ID count, which we're also gonna increase by 1. Okay. Okay, now we have all the information we need. And we don't need this now. So here we make an easier representation to work with. And now we just go through everything. So while right is bigger than 0, try to move the file at index right. All right, so we try to move the file. So file is gonna be this disk part map of right. Now we go from the left, I equals 0, I is less than length of disk part map, and I plus plus. Well, we actually have to do it 1, and we're going to increase by 2. We need an equal sign as well. And before I forget, I'm going to decrease the right pointer by 2 as well. So now go from left to right and try to find a place for this file. And also this has to be actually lower than right. All right, so now we just do it like that. If disk part map of, oh, actually we have to go from 0, and we're gonna check in the for loop because the places can change. So disk part map of I dot id is not equal to is equal to -1. Then that's a free space, that's a candidate, and this free space has to have more space than size has to be larger or equal to the space of the file. Now, if that is the case, we have found the spot. So we put the file here. How do we do that? We say disk part map of I equals file, and disk part map of write now equals nil, or not really nil. I'm just gonna, so I don't have problem with references, I'm just gonna do it like disk part, and I'm gonna put 0 and -1. And when we're done, make a compact array. Which we were gonna make by, I guess, just going by going through the disk part map. Actually, I'll be right back. Okay, I'm back. So we have to convert the disk part map to the same structure, so this compact array as we had before in part 1. So we're just going to check if l.id is not -1, what are we gonna do? We're just gonna for I equals 0, I is less than dot size I. So what are we? So let's just do it like that. ID equals 0. If ID is not free space, we're going to set it to element.id. But in any case, we're gonna append to the compact array less than less than what? Element dot size, and have to increase the I. Okay, and we just append. So compact append. We append the ID, right? And yeah, I think that's it. Let's try running this part 2 disk map, and let's just print it out. Compact 2. I hope we're not in some kind of a loop right now, infinite loop. We shouldn't be. All right. This doesn't seem right, but let's see. Zero 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 6 7. This is not. So let's print out the disk part map as well. So I have free space at the beginning, which is not good. 0 0 0. How could I place free space at the beginning? That's not. Right, doesn't matter, but what I'm wondering is why am I getting so many zeros? Did I mess up somehow? No, it looks fine here.